Thanks, Eric, and thank you, Anna and Gabe, for a wonderful overview of UCSF Health Decarb strategies. Please allow me to introduce myself. My name is Maria Canwell. I'm a final year PhD student in the Energy Graduate Group at UC Davis, and I'll be your MC for today. I'm taking over now, and I'd like to thank Kurt, Josh, and Eric for taking care of things for me. I'll also be helping us stay on schedule. So just to mention that I may need to gently interrupt if we start to run over time to make sure that everyone has a fair chance to present and we keep the program running smoothly. So yeah, we're now going to move into our first session, which is the UC-wide report out, moderated by Eric Eberhardt and Josh Morejohn. So take it away, guys.
Josh can join me, but we're going to kick off our second and arguably the most information dense session that we have today. We thought, how can we deliver as much useful and interesting information in the shortest amount of time across the most locations? And this is it. Josh came up with it. It's going to be an interesting experiment. We're going to have report outs from every UC campus and health location, along with one of our national lab locations in a single session. That's right, you heard it. So we're going to make it happen. One way we're going to make that happen is be very diligent about time and folks presenting their single slide and summary information across roughly 3 minutes. So we're going to give that a shot. Josh, you have anything you want to add?
Just that the goal of this is to not let anyone fall asleep. So we're going to try to keep it fast paced and interesting. And like you said, a lot of information, but just really high points from each campus. The goal is really to give you guys information so you can ask and follow up if any of the campuses are doing something that is of interest to you. So I'm excited that people are finding the Q&A box now. So keep putting questions and this last session was great. Got a bunch of good questions. I can tell there's a lot of technical people here. So Gabe and Anna are going to be answering those. And then as more questions come in, you'll be seeing those answers pop up there for everyone to see. So I think we're ready to go, Eric, and we're already 2 minutes behind schedule. So should we dive into it?
Let's do it. And you're going to kick us off for
Yeah,
UC Davis. We're
I
moving
got to
from north to south.
set the bar really high here. I'll keep it at 3 minutes. And I just got 3 main points I wanted to touch on with our UC Davis updates. We talk a lot about our district heating conversion. We call it the big shift. And we started construction on it back in 2020 and finished the first phase. We are now on the second phase or district of converting buildings to hot water from our steam system. That's exciting. It's under construction right now. We'll be finishing up that district over the next 2 years. Then we'll have about 70 buildings on our campus on hot water. The catch is that we've still been making that hot water with steam through heat exchangers we bought from Stanford. So the real key piece is that we need our heat recovery chiller plant built. And the exciting news is that we've awarded that contract. And it's a design build contract. So we're finishing design on that and are starting construction next year, early 2026. We'll be putting up the plant in the summer of 2026, and that'll go about 2 years. A heat recovery chiller plant along with the thermal energy storage tank for hot water. You'll hear more about that later, so I won't spend any more time on that. Real quick on ground mount solar, we're expanding our really large 15 megawatt site with another 5 megawatt system, hopefully in 2026, trying to take advantage of that investment tax credit. And then really exciting, some of the pictures on the right here show an agrivoltaics installation that went in just last week with 450 kW research plots that we can talk about with anyone who's interested with a researcher, and that's tied into our campus grid. And then last point is we talked about our biodigester in the past. We're installing one, hopefully 250 kW linear generators in 2026. That's it.
Excellent. We're passing it off to Davis Health.
Yeah, I have 6 major points. First is the hydronic optimization. As a part of our master plan to meet seismic compliance for hospitals, we were able to hydronically separate from the campus loop our north and south wing, which is basically equates about 600,000 square feet of hospital. That was originally built in the 1920s, and so it's time for that building to sort of go away. And we're in the process of building our replacement tower right now. This hydronic separation has allowed us to significantly drop our minimum flow in our secondary chilled water loop, which basically allows us to turn off some of our larger 700 horsepower pumps within our central plant. So with fewer chillers operating, maintaining our campus cooling, we've been able to improve efficiency. On item number 2, improved performance from new chillers. We've just recently opened a new surgical center, the 48th and X complex, roughly in July of this year, which installed a new centrifugal chiller number 4. It's now become our primary chiller, and it's operating significantly better than all of our other existing chillers. So at full load, it's only about 1.5 megawatts. At nighttime operation, it's around 200 kW. Our chiller that best operates, our older chiller that best operates around that time is really around 400 kW for nighttime operation. So a significant energy savings there. Item number 3, the thermal energy use reductions. With some control optimization that we've been attempting to do, natural gas consumption has gone down significantly. We've seen about 5% reductions every single month since the start of our program in January. So I can get some more up-to-date information on what those reductions look like, but we're hovering around like 5% right now. For the new photovoltaic installations, we just got a 240,000 kW system and a 270,000 kW system, which is roughly equates about 1% of our annual usage of our cogen, allowing us to drop that. And then we've started the construction of our central utility plant expansion project, which is going to expand our chilled water system, our heating hot water system, but is going to start our path to electrification. We're installing a new SMUD 40 MVA connection, and that'll be complete by 2030.
Excellent. Thank you, Wes. You're early. I don't know if other folks can see. We've got a little timer that we're running up in the corner. 3 minutes. We're keeping these guys on task. So I'm passing it off to Bruce Chamberlain at UC Berkeley.
Good morning, and Oski in the lower right says hello and good morning as well. Bruce Chamberlain, Campus Energy Manager at UC Berkeley. I'm going to add more items than the other 2 presenters. It's going to be 10 this time, so different approach. We have a core team of the Energy Office, EMS group, project managers, engineering, and trades that nothing can happen without kind of great collaboration. There's a existing energy policy that is revision in progress, and it covers existing building operations, new construction, large and medium small renovations, clean energy supply, computing equipment, and lab equipment. Planning is underway in our annual holiday energy curtailment, where we lower hot water temperatures and air handling units and lighting. We have ongoing RCX and energy efficiency projects in the HVAC realm, including steam, electricity projects, including LEDs, VFDs, and labs, where there's some great coordination with EH&S. Plan reviews are an ongoing basis, whether new building, new construction, and we're doing several BAS upgrades from obsolete control system to ALC. Utility meter and data management is ongoing with coordination, EMS group, design engineers, campus IT, electric shop, and SkySpark consultants. So that's a critical piece that feeds into our energy management and information systems, which includes a public dashboard, energy management internal dashboard, and is based on SkySpark and Energy Cap. We have, as many have heard, the Clean Energy Campus Utility Improvement Project, which is essentially decoupling from our primary natural gas fueled cogen plant to an electric heating and cooling plant. Phase 1 is about 35 buildings. Construction starts in mid-2026, and we're at 100% DD now, and we're targeting RCX on building conversions on those 35 buildings. We've got solar PPAs that are on the hunt before summer 2026, quarterly energy reports to divisions, on-campus academic divisions to show performance regarding the 2% annual reduction that UC strives for. And we've got successful tariff rate optimization study. We're going to have significant savings based on our cogen rates, mostly through Procure America. And lastly, go Bears.
Well done, Bruce. Moving on to John Elliott at Lawrence Berkeley National Lab.
Hey there, I'm John Elliott, Chief Sustainability Officer at Lawrence Berkeley National Laboratory. The big news, at least from our perspective here at the lab, is that my group, Sustainable Berkeley Lab, is now part of the Facilities Division. This reorganization was done in part to leverage the data engineering and building analytics skills of our ongoing commissioning team more broadly across operations. That team, which works continuously and I'll add cost effectively to improve building operations and save energy and water, is going strong. They've completed 95 sprints, monthly work sprints over the last 8 years. They've resolved over 1,800 issues in a portfolio of 40 buildings. Chris Wyant, the leader of that team, will be talking later today more about OCX. We're working on 2 new initiatives with our facilities colleagues. The first is condition-based maintenance. So we're starting with air handler filter replacements, working to move that preventative maintenance activity from being done on a time-based interval to being based on filter loading. And we're also getting deeper into alarm consolidation, getting alarms from several different alarm consoles across the site into one place and doing analysis and segmentation of those alarms and some logic reprogramming to move our alarms in our building automation system from overwhelming, I would say, to hopefully effective and manageable. A few notes about building electrification. We did have 2 significant projects, boiler plant electrification retrofits that had gone through conceptual design and were ready to move at the early part of the year. And those are not moving forward under the current administration. But electrification is going strong in new construction. So we opened our 3rd major new electrified facility. That's a laboratory called BioEpic that's shown on the right in this picture. We hope it'll operate as efficiently as its sibling, which is that integrative genomics building, which is shown on the left, that we've operated since 2019. That building has been operating as it was modeled in design at 35% of the UC laboratory building performance benchmark. We also have an all-electric new cafeteria facility under construction. I will note, as the last item, we do continue to find heat pump operation challenging. And so we've started another initiative that we call the Heat Pump Center of Excellence. Our goal is to stay on top of and be excellent at operating our heat pumps and sharing data, real-time operating data through SkySpark with others. So this is in development now, but maybe someday soon, we can be sharing best practices and data from operating heat pumps across the UC. And that's it. Thank you.
Thank you, John. And just to echo, we're going to be seeing more from LBNL and Chris later in OCX. Moving on to Ben at UCSF.
Okay, hopefully I can avoid that nice music. So at UCSF, we've gone from sort of looking at trying to be decarbonization focused, but in light of all of the changes that have occurred in our budgets, we're now really emphasizing energy savings. And so there's 2 big main thrusts that we have. One has been this thing that that Bruce talked about, the tariff optimization work, that some of it's been done by Procure America, some of it has been done just by internally our team. And we've managed to save a good $1.6 million. That's net after all of their fees, which are, as people know that work with Procure America, they're substantial and ongoing. And so we hope to see the day when we don't have to pay that in about 3 or 4 years. So that'll be good. But in any event, it has saved us a lot of money on things that we didn't really realize, one of which is this low variability microgrid, we call it, which is the Parnassus cup that essentially requires no reserve capacity now from the grid because it's designated that. And the reason it's designated that is because we have assured PG&E that we will take renewable gas as soon as it is technically and economically feasible to do so, which is probably never, but all you have to do is state that, and also have PE, which is myself, to essentially be able to take responsibility for that statement. Okay, and then secondly is the big program that we've started here is called Layer Up for Science. It has a target of about $400,000 in savings per year. And we've already done it on a few buildings, about 20% of our buildings in Mission Bay. And it's already has a pretty good run rate. We're saving $40,000 over about a 3-month period on 22% of the buildings that we've done. So we still have a lot of buildings to complete. The buildings that we're going to be completing later are the ones that require a little more commissioning knowledge or commissioning changes and reprogramming controllers. But so far we have really good success with this program, and we worked with the Center for Built Environment a little bit on it, and our people have to work closely with the engineers here and all of the faculty and students that complain or have issues. So that's it.
Excellent. Perfect, Ben. And I'm going to remind folks to please put your questions in the Q&A as we go, and we can circle back as we finish up here. I'm guessing there's going to be a lot of questions because there's a lot of information coming out. So passing it off to Jacob Huth at UCSF Health.
Thanks, Eric. Yeah, good morning, everybody. You heard a little bit about UCSF Health this morning from Anna and Gabe, but to provide a little bit more detail, we're really focusing in on working on those two new carbon neutral surgical centers. So that has been a big focus over the last year and a half or so, as well as the 2 new hospitals that are in construction, which are across the bay from each other, one in San Francisco and one in Oakland, and as well as those surgical centers, one in San Francisco and one in the Peninsula in Burlingame. Our decarbonization plan focuses heavily around heat recovery chillers, as well as some of the other technologies, thermal energy storage, air source heat pumps, and as well as using natural gas boilers as backup heating for the hospital, since we do need to maintain additional resiliency for those critical buildings. Combining funds has also been a major point for UCSF Health. We were able to get $50 million in SEP funding for energy efficiency, and currently are running projects in retro commissioning, LED upgrades, HVAC control upgrades, operating room airflow setback has been a big focus. There's a significant amount of savings to be had from turning down the airflow in operating rooms when they're not in occupied mode, as well as putting in heat recovery chillers where possible at other plants. And we're pursuing all these to combine SEP funding, capital funding, and biogas sales. So being nimble about where we can find funding and where we can partner, where we can add opportunities to existing projects. And sort of alluded to this, but the footprint has expanded greatly. We have these new hospitals under construction, as well as the 3 additional hospital campuses in the last 18 months. So that has been a big focus, getting all of those new hospitals, new to UCSF Health in our portfolio, moving those to carbon-free electricity, things like that, and finding opportunities for efficiency in all of those buildings. That's it for UCSF Health. Thanks.
Hey, Jacob finishing early, extra points, or actually we shouldn't say that. Use your full time, max out that information. Okay, again, please keep the Q&A coming. Jim Brugger at UC Merced, turning it over to you.
Hey, thanks, Eric. Appreciate it. Good morning, everybody. I'm going to take a different tack here and share some bumps and bruises. I guess I can say I'm adding some black and blue to our blue and gold. But I'm basically what we're challenged with is the aspirational policies that we have, trying to balance that with operational realities. And so what I wanted to share out real quick was in the middle of our decarbonization study, we lost over the course of about a year and a half or so, we lost all of our heating plant that serves our main academic core. And as we were going through this, we did a design, we started the process of doing a boiler replacement with natural gas fired boilers. But since it was in the middle of our decarb study, we got a lot of pushback asking, how come you're not putting in electric boilers or some electrified solution? How come, we're supposed to electrify our existing buildings. How come you're not doing incremental electrification? And what our study showed pretty clearly is that we have an all or nothing solution. We don't have a lot of opportunities for incremental electrification. And one of the stop gaps that we had to do as our boilers failed, after the first one failed, in fact, we started renting boilers. So we currently have 9 rental boilers firing our heating plant at a cost of about $35,000 a month. While we're trying to get this replacement going. And that real estate is needed for heat pump technologies, other things that we're going to implement as part of our decarb strategy down the road. And so we actually had to bring our consultant back in, and they said that heat pumps are notoriously prone to failure, and having natural gas fired boilers as a backup source is smart. So going back in with high efficiency, low temperature boilers that we can test our loops, test the technology, make sure our loops can handle low temperatures. That gets us a lot of flexibility and a lot of operational knowledge to prepare for electrification down the road when we get there. And that was it. Oh, and then just one quick, we are doing a PPA for expanding our solar with agrivoltaics. So I'm hoping that'll be done by next summer. Thanks, everybody. Appreciate it.
Jim, since you've got 50 seconds left, Jordan's asking what was the mode of hot water boiler failure? Is it a quick answer?
Oh, yeah. Quick answer. To the best of our knowledge, bad chemical treatment. We've had leaks in that loop historically over time. We think some bad chemical treatment led to tube failures. All 3 of them, one by one, blew a tube. So we assume that it was something with corrosion, but we're not 100% sure. Yeah, good question.
Thanks.
Okay, we're turning it over to Patrick.
Hey everybody, good to see you all. I'm Patrick Testoni, Director of Energy Management, UC Santa Cruz. I figured since there's so many breadth of information, I'd focus on what we're doing that's a little bit different. We're doing a little bit more focused in non-energy efficiency. We're doing microgrid projects on the campus. So I'll focus on all of these. There's a lot of information here and there's a short amount of time. So I put all this information here. If you have any questions, it's pretty informative. So we've begun multiple microgrid projects. It's been driven by resiliency. We're at the end of a distribution line and we lose power a lot. It is a high priority focus of our academic research and our administrative. So we've been leveraging this. So I want to first give a shout out to our team. I'm presenting on it, but our decarbon electrification project manager who's here, Phil Boutel, has been amazing working on these projects. Matt Porter, who works in energy management, came to us with a long background in solar and batteries. And also we have a real estate director who is very proactive, which is important since these are power purchase agreements. Unique features, this MBEST one is Monterey Bay Extension, small academic buildings, remote, a good place to start practicing resiliency. That is in construction, full resiliency with battery and EV charging that the vendor is selling.
The police station is the second project. What's notable about this is the police station. It's on our main campus, but it's not on our main campus feed. So our police chief was very supportive of creating a resilient building that could fully operate with power outages, which it is. It has EV charging for their electric vehicles as well. You'll see a common theme of 4-hour batteries. One of the projects that's in design right now with an estimated completion of fall 2026 is our new kind of research. It's where we're putting in our engineering faculty. It's on the west side of campus, west side of Santa Cruz, about 1 megawatt of PV with solar and battery. This will be like a critical load microgrid, so a sub microgrid. And then our family student housing project, which is heading towards construction completion. What is very cool about this project is there's no generators. It's all electric, and we're using batteries to provide critical load microgrid for the early education center and kind of a meeting space for the people who live there. And then finally, we're working on the main campus. All this work has been building up for how can we make the main campus more resilient. We deal with outages, they're problematic, they create a lot of angst. And so all this information our team is using to feed into creating a sub microgrid for our critical loads beyond our cogen to enhance resiliency with our cogen. On top of that, we're kind of doing some cool work. I want to give out a shout out to Gabe Sandoval. We worked together, and he generated a lot of work here that he's left his lasting footprint here. And we're continuing working with SkySpark and Energy Cap and water leak detection. That's the last thing I want to give a shout out for. If you ever want to find out more about it, just ask me about it. That's it.
Perfect. Thank you, Patrick. And turn it right over to Jordan.
All right.
UCSB.
Thanks, Eric. I kind of cheated here. I put a few slides onto one, but I'll keep it under 3. So I want to talk about our hot water expansion and electrification project. 2 years ago, most of us here were involved in the creation of our decarbonization studies, and we turned those deliverables over to the UC Fossil Free Task Force last fall. And following that effort, UCSB were able to parlay that into a detailed project program, including cost estimating for a concept that resembled what we came up with in our clean energy master plan, but sort of riffed on some of the technologies. I'd say more importantly, though, led the campus to agree on a site for the central plant. You can see that on the bottom left slide, the new heating hot water distribution network, and that dark blue kind of polygon in the top center of that image. That's the central plant location. So took a little bit of inspiration from San Diego and are budding this plant right up to an existing parking garage with our new TES and our central plant equipment. UCSB is the only campus currently without some form of central heating equipment. So, that means we've got a boiler plant at each of our major buildings, totaling about 100 million BTUs per hour of capacity on the campus. And so I'd say the deferred maintenance liability, just the general daily operations of a setup like that are disproportionately high. So we're able to show some of the economic benefit of this plan in the form of avoided replacement of that 120 or so heating hot water plants across the campus. This is a substantial investment for us. We've broken it down into 5 phases. We're looking at total investment of $800 million over the next 20 years, with $250 million estimated in phase 1. Effort to maximize kind of the impact for phase 1. You can see about 50% of our emissions are represented in those dark red and orange kind of heat map image, are in 23 of our buildings. So phase 1 connects those 23 buildings, and then phases 2, 3, and beyond kind of get some reduced marginal returns on investment. But phase 3 is scheduled for completion roughly 2040, and after that point, we've got about a 15-year simple payback period. So it's actually quite a promising project. So big changes afoot. New chancellor in September, and we're hopeful about financing.
Excellent. Thank you, Jordan. That was perfect. Moving south to UCLA and Sean Wilder.
Good morning, everyone. So I just wanted to highlight our top three takeaways from 2025 that we're wrapping up now. So our big one was the cogen. As most folks know, we had to repower our entire cogen to meet AQMD new AQMD standards. Also, we had some reliability and parts issues associated with that powerhouse, which had been going, I think, since 1994, or like a little bit before the Northridge earthquake. So we have new turbines in there. They run more efficient overall. They give us some redundancy. The key takeaway from those is that we can, off the shelf, we can use 10% hydrogen blend if and when DWP finishes up a program they're working on, see if we can split off some of the trunk that they had planned for hydrogen supply to Scattergood. But the capability is there. We also got a very nice award. Cogen is a very small, tight space. We had multiple contractors working in there with a lot of folks from those contractors from different specialties working in there. We were able to complete that project with no missed time injuries. So over 200,000 hours worked. We got a nice award for that. That was the thing that kept me up over the last 2 years, was just worrying about my folks working there, because they were working 12 hours on average every day, and then sometimes around the clock on different shifts depending on if we needed to make up schedules. So that's a big accomplishment for the campus. As far as we're focusing on energy efficiency, ways to find money to get to be able to pay for some of this stuff. We developed a customer program, not unlike what you find at DWP or Edison. We just basically went in there and copied what they did. So we take a part of our recharge income, split it off, put it into a pot of money, and use that to promote or further incentivize our recharge customers to work with us on energy efficiency programs. So they'll help them invest. So basically, we're doubling the incentive that the utilities would probably offer. So let's say you have like a 10% funding for LEDs on the DWP side. We're basically doubling that to make it more attractive for our recharge customers to work on their energy efficiency projects in their spaces. And then the third thing here is we're focusing on LED retrofits. We think that we'll be able to meet most of our, if not all of our EUI reduction goals in our portfolio by just focusing on our LED retrofits across campus. We haven't made a lot of progress in there, so there's a lot of low-hanging fruit. And we're focusing on that because it has the quickest turnaround, quickest payback. Sometimes some cases less than 5 years payback. And that's the key takeaway. Thank you.
Excellent. Thank you, Sean. And we're moving sideways across the LA basin to UCLA Health and John Carpenter.
It's technically across the street south, so we are south still. But anyway, so I'm actually going to be talking about a lot of things that are in this slide. So if you're wondering if you got lost in my slide, I'm probably not talking about something that's in there. But I will say we've made significant progress on our climate action plan goals. 7 of our 11 owned and operated buildings have an electrification master plan design or funding in place. Two additional of those 11 buildings will have an analysis in place by the end of 2026. And one of them is currently in the slide, the one under construction, which we completed in the summer of 2026. This was originally an acute care hospital, and the people who own the hospital went bankrupt and we're going to shutter the hospital, and UCLA decided to buy it instead, and we're converting it into a neuropsychiatric inpatient hospital, which will house Resnick Hospital come the end of 2026 after our occupation. And it is going to be the first all-electric commercial kitchen in Los Angeles, as we made an effort to make it all electric. So it's got obviously heat recovery chillers in it and all that 9 yards and stuff. Originally, it was going to be the first all-electric commercial kitchen in all of Southern California, but a different UC building beat us to the punch on that. In addition to that, outside of this hospital, other things we're doing is, as Sean Wilder talked about, LEDs. Approximately 25% of our total floor space has been already retrofitted with LED replacements, and as much as 50% of Reagan, which is our largest acute care hospital, has been replaced with LED lighting. In addition to that, we recently purchased a underutilized lab and office building, which we're converting to the state-of-the-art sports medicine facility. And using some decarb funding provided by UCOP, we were able to use that money to make an all-electric plant as well. So that should take care of the scope 1 and 2 emissions for the building. And so what keeps me up at night? Well, those last 2 buildings that are not part of that plan, the 2 of the 11, we have no real way of making that an electric plant. The reason why is because when it was originally built, they built a big hole in the ground and covered it over with the emergency department for the second largest inpatient acute care medical center. That's part of our system, and it's a regional trauma center, so we can't really mess with the emergency room. So we have no place to put a new plant and no way to take out 3 12,000-pound high-pressure steam boilers. So we're not really sure what we're going to do there, but we're hoping to have a plan in place in the next few years. And they will be sunset by existing AQMD rules, likely by 2037. Right now, there's no sunset date, but the new rules that will be going into effect in 2026 will sunset them in 2037. So now we can pass it on.
Thank you, John, and thank you for calling out my Northern California ignorance to Los Angeles geography. I'm going to pass it on now to Chad Sisko at UC Riverside.
Thanks, gentlemen. My name is Chad Sisko, UC Riverside. Since our campus seems to be a little dark horse in the energy world, I'm going to give you an ambitious goal of 30 years in under 3 minutes. So this slide you see is our enrollment since 1980 with a few facts along the way. And from the beginning of the 80s until the end of the decade, we nearly doubled enrollment, and that required action to be taken to expand our central plant chill water capacity to meet the new peak cooling load demands. And regionally, Riverside was also experiencing pretty good growth, which we ended up maxing out our capacity at our substation at 9.8 megawatts at the time, which is all we had. And we were waiting for utility upgrades in order to increase capacity. So they had to act quickly, and UCR and RPU got together and explored thermal energy storage options back in the early 80s to essentially just shift the on-peak loads and provide the campus with additional cooling capacity. And this resulted in the installation of our first 2 million gallon chill water thermal energy storage tank in the early to mid 90s. And then throughout the 90s and early 2000s, we had a pretty relative low cost of energy, and it made most efficiency efforts financially unattractive. It wasn't really until the early 2000s, around 2005, that we nearly doubled enrollment growth again to over 15,000. And we took advantage of new energy efficiency incentives to install TES2, along with a new satellite chiller plant. And in 2013, we finished our third TES tank, bringing our total chilled water TES system to almost 7 million gallons with over 60,000 ton hours of capacity. In 2016, demand charges first appeared on the bill. That was the first time we had seen them under the new RPU time of use rate structures. And UCR, recognizing the need for utility and energy management, first hired their director in 2019, who started this department. So we're really new. Since then, we've installed utility metering at over 50 core campus buildings. We've identified efficiency projects in more than 15 of the buildings and totaled more than 5 million kilowatt hours of electricity savings, 8,000 MMBTUs of natural gas savings, and over 1,400 metric tons of CO2 equivalent in energy and emission savings since then. So most recently, we completed a study to explore what it would take to decarbonize the campus, and we find ourselves in a pretty good spot to take advantage of this load profile. So thank you.
Thanks, Chad. And we are now moving on to Irvine campus. and Joe Fleshman.
Hi, I'm Joe Fleshman, Director of Energy and Engineering at UC Irvine. Really, our story has been to date really 3 decades of energy efficiency. We have basically done half the work to decarbonization through aggressive energy efficiency over the past 30 years. The graph that you see here, the blue line is your business as usual based on square footage growth that the campus has experienced since the 90s. And the green line is what our actual energy consumption has looked like. So we're using about the same amount of energy as we did 30 years ago. We installed a 4.5 million gallon thermal energy storage tank in 97. We have a cogen that we put in 2007 that lets us get double benefit of the gas that goes into the cogen. And then we were an inaugural member of President Obama's Better Building Challenge. It basically beat the Better Building Challenge when it started because of our aggressive leadership in energy efficiency. We do deep energy retrofits, especially if you haven't, UCI is world renowned for its Smart Labs program. We do aggressive energy air change reductions in laboratory buildings. So we basically, like I said, we've done half the work already. So that means that when we go to decarbonize, the amount of heat generating equipment, for instance, that we need to worry about is half of what it would be otherwise. So through our decarbonization activities that we're currently doing on campus, we're continuing to drive down energy use through retro commissioning. I'll be talking about operational commissioning a little later this morning as well. We're working through some of the results of our decarbonization study, working with Edison on bringing a second 66 kV line to campus to deal with our expected electrification and electric growth. The cogen is responsible for more than 90% of our scope 1 emissions, but we do have some gas-fired equipment that's campus owned and operated that I am currently finalizing scopes of work so we can get those physically replaced. We're scoping a solar and battery business case study to see what we can do beyond the load shifting that we're already capable of with the TES. What does kind of electric storage look like? And then we're coordinating on the energy side very closely with our sustainability group. A new long-range development plan is currently in progress. Our last LRDP was 2007. And we're incorporating decarbonization findings into the utility growth requirements and, informing the climate action and adaptation plan as part of that.
All done already, Joe?
I was watching the timer and I think I was about 3 minutes.
Next, thank you, Joe. That was perfect. And again, just to plug what Joe said, he's going to be talking later about their OCX program along with some other campuses. So I'm looking forward to that. But now we're going to hand it over to Tony Dover, also with UC Irvine from the health side. Tony, take it away.
Good morning, Tony Dover, Energy Management Sustainability Officer with UCI Health. Just like other UC locations, we have a climate goal of 90% by 2045. Here at the health side, we also made a commitment to the White House pledge, which we still are committed to, for an interim goal of 50% for scope 1 and 2 by 2030. Our chosen decarb pathway is electrification, mainly. Most of that comes from electrification of our central plant here at the Orange campus, which is our largest and legacy campus. But what do we do about that remaining 10-15%? We recently completed a project that supports removing that remaining 10-15%. And so we started off by doing an inventory of all of our fossil fuel equipment, fossil fuel powered equipment, and focused on reducing and replacing our natural gas water heaters at our non-OSHPD, non-HCI facilities with electric heat pump water heaters. I was able to leverage an incentive program through Southern California Regional Energy Network. It was an expedited program that covered 100% of the cost of the project. So in this project, and if you just hit the next button, you'll see the new water heaters. I was able to leverage money to pay for 12 gas water heaters that were all beyond their useful life with electric heat pump water heaters. The project cost was just under $400,000, which UCI Health paid zero. The incentive program covered all the equipment, all the labor, all the electrical upgrades that we had to do in order to have electric heat pump water heaters. And we eliminated 65,000 therms, and you can see the savings there. We all know budgets are tight. And so I would suggest looking into any local incentive programs to leverage the money to fund energy efficiency and carbon reduction programs. So the new heat pump water heaters advanced our decarbonization goals, and reduced our energy use intensity, and also improved our reliability across the healthcare facilities on this campus. And if you just hit the next slide, you'll see the new water heaters. Who's ever in charge of the next slide? There you go. Thank you.
Thank you, Tony. And I think we have a couple seconds left. We had a question just real quickly in the chat about the water heaters and what refrigerant they're using. Is it CO2 or something else?
That I don't know. I need to look into.
Okay, we can get back to you on
Pretty
that
sure
one.
those were standard heat pump water heaters, which are using
Yes.
like a typical refrigerant, 410A or something.
Okay. And another quick question, since we're doing great on time, from Ben. What was the size of the water heaters in total, if you know that off the top of your head?
What were the size in gallons?
Yeah.
They were I think 120.
Okay.
Yeah.
Excellent. All right. And we are doing shockingly well. We're moving down to our last campus that has both a campus and health system, down to University of California, San Diego, and Michelle Perez. Take it away, Michelle.
Morning, everyone. Oh, 1 second. You all hear me? Great. I'm Michelle Perez, Interim Director of Utilities and Sustainability at UC San Diego. I'm really excited to share a little bit about what's going on down here at San Diego. Our group is super awesome. We've got the central plant with us, our metering shop, and also sustainability and our utilities enterprise. So really fortunate to work with these fine group of gentlemen and ladies. Some exciting things that happened just this week. Actually, we just we replaced one of our turbines. That doesn't happen very often, every 5 years. So it's really cool to see that come out and be replaced and get up and running within a week. So proud to talk about that and just share that. In the areas of energy management and efficiency, we're building off a pilot project that we did through the Global Climate Leadership Council. We had some money for a pilot project, and we're expanding now with the Higher Education Efficiency Program, which is a local, it's a California state funded program through the investor-owned utilities. We're doing that with a really great cross-section of campus partners. Not just what we've done in the past was focus a lot on our lab buildings and state-funded buildings, but this time around we've broadened our reach and created a network with our housing partners, our recreation facilities, our university centers, our student unions, and also our med center team. And Associate will speak later about this potentially. It's really cool to kind of develop that network and share best practices and see the light bulb kind of hit, like, oh, these are some really low hanging fruit things that we can do. A lot of folks have mentioned the budget challenges. So not being able necessarily to do some of the capital projects that we know we need to do, but really finding some easy wins. It's been really nice to feel folks have a little bit of success to build momentum. So hopefully when the tide does turn, we're able to really get the support and budgeting for some of those larger projects. So it's nice to be able to develop that and grow our network on campus. In the areas of resiliency and adaptation planning, along with our decarbonization planning that all of our sister campuses did, we were fortunate to have this really great timing. Our long-range development plan was also being updated at the exact same time for our La Jolla campus. And we also were able to do some climate adaptation planning all at the same time. So really it helped us do a lot of this in concert rather than having these distinct projects and planning happening separately in silos. made it kind of difficult, probably from the standpoint of trying to really coordinate, but it really created, I feel, a really well integrated product. And then finally, in decarb planning, we are moving forward with some studies for our 69 kV substation that will be basically an additional point of connection with the local grid on our West Campus.
Excellent. Thank you, Michelle. And now you know what it's like to win an Oscar.
Thanks.
We're moving on to our last location, but definitely not least, UC San Diego Health, and Sozi Rayner. Take it away.
Hello, and UC San Diego Health. I'm not sure where we have three medical centers, and each of them was very unique in that they have unique challenges. Our oldest hospital, Hillcrest, is approaching 75 years old and is slated for demolition in the next 5 to 10 years, depending on who you talk to. And we also have a new old hospital we purchased is on the order of 60 years old, the East Campus. And then our newest hospital, La Jolla, which is located next to our main campus. One of the things that surprised me when I got here is, all three hospitals were slated for getting new chiller replacements for differing reasons when I got here. And not just new chillers, but new, standard chillers, not heat recovery chillers, nothing sophisticated, nothing that was really going to help our decarb goals. I came as an energy engineer and looked specifically at Hillcrest and found out that a lot of our problems at the system there were hydronic related. They weren't really a capacity shortfall, but rather a distribution shortfall. And we developed a project to offload some of our more intense loads, mainly ORs, where dehumidification, where California's most hottest, humidest climate, so dehumidification loads, if you try and run your whole system, really present a challenge there. So we were able to find a project to actually offload some projects, and that's under progress. And we have shelved for the meantime the idea of putting a new chiller in there to add capacity. Our East Campus hospital, we purchased that about year and a half ago with actually was running on temp chillers. So putting in a new chiller there was in a deep analysis decarb was not really feasible. So we did install new chillers to replace the failed chillers that were failed when we purchased that. We have a lot of capital projects in lined up for there, and I'm relying on our capital projects team. Though recent layoffs at UCSD Health has really hit the energy management team pretty hard. So I'm wearing a lot more hats than I used to. And then finally, La Jolla, our biggest facility, is what I spent a lot of time focusing on recently. It was 3/4 of our health system there is less than 20 years old. I'd like to say that it was built with a traditional non-decarb mindset. And so in a lot of value engineering that took, for example, direct bury of lines when originally tunnels presenting challenges for running hot water and heat recovery. So I'm really refocusing my intent there on trying to make that decarb ready. We're focusing on removing the remaining pneumatics, focusing on improving feedback if we need to replace valves using energy valves, and then also implementing SkySpark so we can make optimizations and really focus on the next step, which will be heat recovery chillers and focusing on decarb with our larger capital projects. So that's it.
Excellent. Perfect. Thank you, Sozi. Finishing strong. And I just want to congratulate every single person who just went through this exercise. And again, it worked amazingly well. So nice work, everyone. We do have a lot of time for Q&A because we have so much information here. So please, folks, feel free to put any questions into chat, or we can take them. Josh and I can also just kind of facilitate some general questions across all the locations or specifics. Josh, I don't know, do you have something specific you want to start with? I have a couple questions I can ask as well.
Yeah, I have a couple. I know a lot of you had more you wanted to say, so this is your chance. If you do have something, let Eric or I know if you wanted to give one more plug or mention something or jump in on an answer. There's still some questions coming into our Q&A, so please put them in there. But one that's been in there since the beginning of this session, because I don't know exactly who it was directed to. Maybe maybe John Elliott, but I think this is actually a good question for all of the campuses. Have you encountered challenges with the existing maintenance manpower not equipped with working with the increase in the number of heat pumps on campus? So basically, is additional heat pumps creating issues on the maintenance side? You know, I can say from the UC Davis perspective, we're installing a heat recovery chiller plant right now, and we're actually replacing our two oldest chillers with heat recovery chillers. So we're not technically increasing the equipment in a significant way, but we're doing that in a centralized way to try to manage that effort. There's still some new technology, but we're going with you'll hear more about these later today, but we're going with technology that's not that different. I think the challenge is going to be more for campuses that have distributed air source heat pumps. One of the big challenges we've had, just practically speaking, is that if you put in refrigeration equipment, now that load falls on our refrigeration shop, and if you're shifting that, say, from hydronic equipment or boilers, that might be a different maintenance shop. So, you know, you're shifting workload between different shops. And so there is some balancing that has to happen there. And certainly more distributed equipment can add, you know, to workload and can be a challenge. So wanted to see if any of the campuses wanted to jump in on that one and answer it.
This is Bruce at Berkeley, and I would agree. Well, I just add to that it's not only heat pumps, but other new equipment as well, VRFs, which you touched on with refrigeration, heat recovery chillers, HVAC, lighting, control system interoperability. All these things have a level of sophistication that, frankly, the maintenance operations staff and crew are not trained up on. And we rely on essentially the training that occurs on, you know, completion of construction projects. And those trainings are usually template trainings from the, you know, contractor, and they last maybe an hour or a couple for most. So there's a huge need for training and upskilling.
Great. Yeah, Kenny put an answer in the chat as well, in terms of shifting the skills. One additional comment I can mention that we've done on the UC Davis campus, where we had a plant that was had steam heating, and this is a smaller remote plant at our primate center. We replaced those steam boilers with hot water boilers and a solar thermal system and heat pumps. So it's a fairly advanced system, more complex, but didn't need to have the 24/7 supervision that the gas-fired boilers needed. So we actually were able to pull back operators to our central plant instead of having them stationed at this remote plant. And we needed less operators overall, but we needed more maintenance staff because of the additional sites that we had to maintain. And so we were able to actually split our operators into an operations crew and a maintenance crew. And then the maintenance team was focused on maintaining the additional equipment and additional sites. And the operators were just focused on operating the central plant. So I think if you're creative, there's ways you can address it. I mean, certainly maintenance goes down as you replace some of these old systems with newer systems. For example, steam is a pretty high maintenance system for us, at least. But the challenge is that some of this newer equipment is also more complex and more technical. So any other comments on that before we move on to another question? I've got
looks like Jim had a comment.
Oh, go ahead,
Jim Brugger.
Yeah, thanks, Josh. I thought I'd just chime in too. That's one of the it's always sticking in the back of my mind too. We don't have a lot of heat pumps yet, but that is a challenge that we're definitely thinking about. It's on the top of our mind about distributed maintenance. We're currently in the process of construction or design of 3 buildings, all going electric And just looking at the heat pumps and the technologies that are on a couple of those buildings, one's a 300,000 square or 200,000 square foot med ed building. A lot of distributed maintenance, basically, that we don't have the staff and don't have the technical capabilities to deal with right now. So that is definitely something we're nervous about and looking forward to figuring out how to adopt and how to meet that challenge going forward.
I will say, just if you blindly electrify, it can create a lot of problems on the maintenance side. We've experienced that by just putting in, for example, VRF systems. We have a couple buildings that were not connected to our central district systems, and had real bad experiences with VRF systems in terms of the maintenance workload. And in the future, we're looking at putting in where we can. For example, we have a building that's getting built that's too far away from our new hot water loop, probably isn't going to be able to get hot water to it in time. But it's the chill water's there already, so we're looking at whether we can do a basically heat recovery chiller to make hot water for that building, and then later when we bring hot water over, we'll have that heat recovery chiller in place already if we want to have a remote plan. But definitely, if you can go with, for example, hydronic or water to water, that can be a help on the maintenance side compared to air source equipment.
Yeah, our new buildings, we've actually stubbed pipes for the future. If we ever get a new utility plant on the south part of campus, the idea is that it would be all electric with a lot of heat recovery technologies. It's more centrally located to backfeed and lay up some of the distributed air-cooled equipment.
Great. One question I have I think Jordan mentioned this, so I'm going to put him on the spot, but we all have the challenge of funding projects, and in the current budget times, that can be hard to do. One strategy can be looking at avoided cost, but that doesn't always have a lot of weight with finance people that are managing the budget, because it's not a real cost until you actually have to spend it. So, for example, if you're replacing old equipment that you would have had to replace, you can't always get credit for that cost that you now don't have to spend in the future, and it doesn't generate any dollars in your budget right now if you didn't have that money to begin with. It's certainly a strategy we've used to help make the case for example, for our big shift to hot water. But wondering, Jordan, you mentioned that, I think, can you speak to that at all?
Yeah, I've often thought about that, Josh, in the course of all the presentations and all the communication and outreach we've done on our project. And there's a big difference between a maintenance liability, a large DM liability as it's presented in a single large steam distribution system versus 120 boiler plants of various size and age and condition. And telling that story has been difficult, because you're right, you're trying to piece together 20 years of potential avoided investments. And once you start to peel back the assumptions and the variables that you're using, for example, what is the expected lifetime of a 2 million BTU hydronic condensing boiler? Is it 15 years? We've seen less than that, but most of the folks here who have been here a while and are responsible for funding deferred maintenance projects are still thinking about atmospheric boilers that we've had in place for 40 years. And so the paradigm is really changing with our distributed heating equipment and what we can expect to get out of it, and the DM liability that we expect that to generate going forward, right? And what's the source of those numbers? Our cost estimating for 1 BTU per hour of heating capacity. What is it, and where are we pulling those numbers from? Is it ICAMP? Is it recent projects where we've had hard bids come back for similar types of projects? So yeah, you're right. You really need a lot of education and data on the front end to even engage in those discussions, and in the context of hundreds of $1 million of investment.
Yeah, thanks, Jordan. One thing we've been able to do is not necessarily get hard credit for avoided costs, but show it as another factor that kind of can tip the balance. You know, you have to be able to pay your debt service with actual budget, but you know, if you have to convince someone that it's worth doing, you can talk about things like avoided costs, operational savings, utility cost savings. Sometimes it's hard to use those as direct savings, but it certainly can help make the overall case if people understand the bigger picture. Well, great. So there's a couple questions in the Q&A right now. I'm just gonna see if we can answer live. This is from Aaron Redding for James and anyone else deploying solar. What timeline are you targeting to sign a PPA or design build contract for PV, or in James's case, agrivoltaics, in order to achieve the ITC savings with the IRA, since that's got some deadlines? Go ahead.
Yeah, I guess to ours, we're focusing on the July 4 substantial construction start deadline. So that's kind of our end goal right now, or our target date that we're really focusing on. I don't know if we have much at this point. It's so late in the year. There's nothing we can really do for safe harbor or anything else prior to that date. So we're hoping that we can get everything permitted and get everything in place to hit that target at least. And since we're doing a power purchase agreement, to me, at the end of the day, it really comes down to pricing. And it's going to make the project much more expensive if we miss the deadlines and miss some of those ITCs. But in the end, if it's cheaper than our grid power, it's not the end of the world, to my mind.
Great. Anyone else have comments on that? All right. For Patrick at Santa Cruz, question for you: what are or will be the primary power sources for the microgrids?
Depends on the location. At these locations, they're getting utility power, but they also have solar. So the solar will be the first energy source for the batteries. Some of them, I think, and I can't remember the specifics on them, but I think most of them are going to be charged by solar, but definitely supplemented by utility for resiliency when needed.
Yeah, and just so everyone knows, you'll get the slides that they'll be posted on the website at the end of the conference or after the conference. So I know you had all that info on there. It looked like they're all grid. Are they all grid tied then?
Yes, they're grid tied with the ability to separate, so they're not isolated.
Yeah. Great. So they all have solar, and that'll be the primary. But
yeah, and it drives the economics of the battery with the S-chip too. And there's other economics too. The one vendor has gotten a lot of value out of creating a retail EV charging station because of the location. So they're selling, it's a PPA, they're selling us electricity and also selling transportation electricity to the community.
Yeah, that's great. Okay. Great. Eric, did you have some questions?
Yeah, I had one open question. I think I saw this in a lot of updates from folks, discussions around the need for increasing capacity from their local utility to address the electrification load increases. And I was wondering if maybe people could talk about quickly just their strategies or approaches they've taken with their utilities to address that, or how they're addressing that, or what they think is an effective way to ensure that they have that capacity they need when they need it, because it is kind of a chicken and egg problem, right? And so it's not easy, and so be curious to hear more. Looks like Patrick can kick us off.
Yeah, I'll kick it off. That was definitely one of the things we discussed when we thought about electrification in our planning. And we actually learned this from talking to UC Berkeley. They did the same thing. We requested a large load study with the PG&E. So it's a process. And I think each utility has it, where you can pay them a certain amount, and you give them a load increase plan, which Phil Boutel, our D&E project manager, put together based on electrification and growth. And then you discuss with them, and we came up with a 1-year, 5-year, 10-year, and 20-year plan, which in our case had some options of bringing transmission or secondary we're actually our secondary primary service, and you know, their opinion basically is that if you build it, will come, but the planning effort helps proactively plan instead of just waiting till you submit new service applications and potentially meeting delays. I found that to be a good exercise that Berkeley did, and we followed and did the same thing.
Bruce, do you want to add anything to that?
No, I think that covers it. I frankly was not in that loop and don't have details on that, so.
Not a problem. And maybe I'll pick on Joe Fleshman if he's still on the call. I know he's doing some investigation just to get an understanding of like methods of service for his campus, because if something was to happen there, it would be a significant increase. I don't know if you have anything that you want to share on how you've been approaching that with Edison, different utility.
Yeah, so we're looking at different technologies beyond just electrification, you know, green hydrogen, things like that. But, you know, the base case really is if other market opportunities and regulatory opportunities don't come to fruition, then electrification is the way we have to go. And so that's sort of our default planning path. And our current projection of load will vastly exceed both our transformer capacity at the substation as well as the 42 MVA. We're looking at 70 megawatts of maximum campus load in 15, 20 years. And we only have a 42 MVA feed from Edison. And so a big part of what we're doing is at least planning for that, because that's realistically a 10-year exercise. Because, you know, you're talking about permitting, we cross multiple authorities having jurisdiction that aren't just the campus, Newport Beach, Caltrans to cross the 73 freeway, and then Irvine, and then to campus. So, you know, we're having to plan as if we're going to have the electrical capacity requirement, despite, you know, our optimism that other technologies will make that not a non-issue, but we'll see.
Good planning, having that in the back pocket, because that's not something you can make happen quickly. So yeah, that's the lesson, is plan early. And I appreciate Kenny's commentary too. Make friends with your local utility representative and keep them in the loop, and you know, keep them you know, engaged, knowing that it may come. So any other thoughts from other locations?
Joe, I had a question. You were the only one out of the campuses who kind of touched micronuclear a little bit deeper than others. Did that ever get discussed at the utility level?
I would say that, you know, we're keeping our eyes open, looking at multiple technologies. You know, that being one of them, green hydrogen being another one of them. You know, with all of the what we call quote unquote emerging technologies, there's both market and regulatory hurdles that have to be, you know, so we're just basically kind of keeping an eye on the market and, you know, planning for electrification, which for us from a, you know, total cost is actually the most expensive compared to, you know, emerging technologies, because we'd have to decommission the cogen, we'd have to install heating capacity that we currently get as waste from the combustion in the turbine. So, you know, those are technologies we're looking at, but we also have to plan for whatever is currently market available, even if it's not our preferred or best option. We have a unique challenge in that we have I think San Diego is the same way as us, though. We have a high temperature water system, not a steam system. It's extremely efficient, and we can serve like 6 million square feet with an 8-inch pipe. And so you know, the conversion to low temp isn't as slam dunk of a proposition on our campus compared to others.